Okay, in this session, we will see how to perform unpaired t-test. Now, first of all, on t-test is a mean test. If you want to compare, mean of two population, mean of two different population, then we need to perform unpaired t-test. But there is some condition to apply unpaired t-test. So, uh, let's see. So first of all, your data need to follow normal distribution. Okay. If your data follows normal distribution, then you can apply t-test. Then you can apply parametric test. Second thing, if your sample is a small sample, okay, and your population standard deviation is unknown, okay, then you can apply t-test. If your sample is large sample and your population standard deviation is known, in that condition you can go for you have to go for Z test. But if your data follows normal distribution, second thing, you have small sample and your population standard deviation is unknown, then you need to perform t test. Now we will talk about the unpaired t test. So when we can perform unpaired t-test. Okay, so if you want to compare averages, if you want to compare mean of two different population, okay, then you need to perform unpaired t-test. Now, T is the ratio of observed difference between the two means of small samples to standard error of differences. Now, what is degree of freedom? The degree of freedom is the quantity in the denominator which is one less than the independent number of observation in a sample is called degree of freedom. So for paired t-test, in paired t-test, we have paired data, means we have two observation for one single subject. Okay, so for the paired t-test, degree of freedom is n-1, means number of subjects in your sample minus 1, and in unpaired t-test, degree of freedom is equal to n1 plus n2 minus 2. n1 is the number of subjects in a first sample, n2 is the number of subjects in a second sample, and minus 2. Now, application of t-test, as I said, significance of difference between two means. If you want to check, if you want to compare two averages of two population or the two averages from the same population, then we can apply t-test. Okay, so there is difference of means are significant or not. If you want to check that, then we can apply t-test. And same as I said, the condition is that your sample is a random sample, and quantitative data, your variable is a quantitative variable. Third condition is variable normally distributed, means your data need to follow normal distribution, and sample size is less than 30, means if your sample is a small sample, then you can apply t-test. Now, unpaired t-test. Applied to unpaired data of independent observation made on the individuals on two different or separate groups, or sample drawn from two different populations. To test the difference between means is real, significant, or due to the chance. So steps for the calculation. First, assume the null hypothesis. Means very first step is we need to assume the pair of hypothesis, null hypothesis and alternative hypothesis. Second, find the observed difference between the means of two samples. Calculate the standard error of difference between the two means and calculate the t value, means t calculated or t statistic. So formula for the T statistic for unpaired data is T calculated is equal to x1 bar, arithmetic mean for the first population minus x2 bar arithmetic mean for the second population divided by standard error of x1 bar minus x2 bar. Okay. Now, as I said, we in unpaired T test we are performing T test on two different populations. Okay, on two different samples. Okay, so we have two samples. So we need to calculate standard deviation for that two population. Means we need to calculate combined standard deviation, also called a full standard deviation. So standard deviation, combined standard deviation is summation x1 minus x1 bar whole square plus summation x2 minus x2 bar whole square divided by n1 plus n2 minus 2. Okay, so under root of summation x1 minus x1 bar whole square plus summation of x2 minus x2 bar whole square divided by n1 plus n2 minus 2. So this is the formula for the combined standard deviation of the two population, and standard error of the difference of mean, standard error of difference of mean is equal to this whole standard deviation, combined standard deviation multiplied by under root of 1 upon n1 plus 1 upon n2. So this is the formula for the standard error of difference of mean. And then we need to calculate degree of freedom. As I said, degree of freedom for the unpaired data is n1 plus n2 minus 2. Then find out the table value of t using the t table and degree of freedom. And what is the decision criteria? So if our t calculated is greater than t tabulated, if our calculated value is greater than our critical value or our table value, then we reject our null hypothesis and conclude that there is significant difference between the means of two population. Okay, so these are the basic steps now, and this is the table. This is the critical value table or T table for T values. Now let's see one example. In a nutritional study, 30 children were given usual diet plus vitamin A and D, and control group of 12 children given only usual diet. After 12 months, the gain in weight were noted as below. Can we say vitamin A and D increase the growth among the children? Okay, so this is unpaired test. Here we have two population. First population is first group is the children who are taking usual diet and plus vitamin A and D, and second is a children who are taking only usual diet. Okay, so this we need to check that the vitamin A and D increase the growth among the children or not. Okay, so this is our question. We need to check this. Okay, so first step we need to assume pair of hypothesis. So our null hypothesis will be mu1 less than or equal to mu2. It means on an average weight gain in a first population is less than or equal to on an average weight gain in a second population. Okay, means on an average weight gain of study group is less than or equal to on an average weight gain in a control group. Okay, so this is our null hypothesis, and second is an alternative hypothesis. This is our research hypothesis, and our claim will goes in this hypothesis. So our question is, can we say vitamin A and D increase the growth among the children? So our alternative hypothesis will be mu1 is greater than mu2. Means on an average weight gain in study group is greater than on an average weight gain in a control group. So this is our pair of hypothesis. Now we need to calculate all these terms. Okay, so for this we create a table. Okay, so x1 is the observation of a study group, x2 is the observation in a control group. So in unpaired T test, uh, two samples, number of subjects in the two samples could be equal or could be unequal. Okay, so it's okay if your first group have more number of subjects as compared to second group. So it's okay if they have unequal number of number of subjects, then it's you can perform T test in that condition also. If your N1 and N2 are different, it's okay. Okay, so X1 is the observation on an weight gain in a first group, and X2 is the weight gain in a second group. So we need to calculate x1 minus x1 bar whole square and x2 minus x2 bar whole square. So what we do, first we uh, find sum of this observation. So sum of x1, sum for the all observation in first group is x summation x1 is equal to 52, and for the second group total is 30. So arithmetic mean for the first group is 52 divided by 13. So in first group we have 13 children. So 52 divided by 13. So x1 bar is 4 and x2 bar will be 30 divided by 12. So it's 2.5. Now what will we do? We subtract arithmetic mean from each and every observation. So x1 minus x1 bar. This is the third column for the first group. Okay, our study group. So x1 minus x1 bar. So 5 minus 4 is equal to 1. 3 minus 4 is equal to minus 1, and so on. And the fourth column is x1 minus x1 bar whole square. So 1 square is equal to 1, minus 1 square is equal to 1, 0 square is equal to 0, and so on. So total of summation x1 minus x1 bar whole square is equal to 32. Same way for the second group for the second variable. So x2 minus x2 bar, 1 minus 2.5 is equal to minus 1.5, 3 minus 2.5 is equal to 0.5, and so on. And last column for the x2 minus x2 bar whole square. And we get summation. So x1 minus summation x1 minus x1 bar whole square is equal to 32, and summation x2 minus x2 bar whole square is equal to 11. Now, as we see, number of subjects in a first group is 30, number of subjects in a second group is 12. Arithmetic mean for the first group is 4, arithmetic mean for the second group is 2.5, and summation x1 minus x1 bar whole square is equal to 32, summation x2 minus x2 bar whole square is equal to 11, and combined standard deviation for these two groups is 1.37, and standard error of difference of mean is equal to 0.54, and our T calculated, our T statistic is equal to x1 minus x2 bar whole square and divided by standard error of mean. Okay, so so our x1 minus x2 bar means 4 minus 2.5 and divided by 0.50. So this will be our test statistic. Value of T T calculated is 2.77. Now, next step, we need to find the critical value, means table value. So, okay. For table value, we need to calculate degree of freedom, and we need to assume significance level. So we take 5% significance level. So degree of freedom is 13 plus 12 minus 2 is equal to 13 plus 12 is equal to 25. 25 minus 2 is equal to 23. Our degree of freedom is 23 and our level of significance is 5%. So, okay. So our degree of first column in this table, first column is for degree of freedom is 23, and in first row is for your significance level. So we take significance level 0.05, means 5%, is 95% confidence level. We are taking 95% confidence level. Now, one more thing need to see, like, this our one tail test or two tail test. Okay, so this is our one tail test because our alternative hypothesis is one-sided. We are checking that on an average weight gain in the first room is greater than on an average weight gain in a second room. Okay, so this is our one-sided test. As we see null hypothesis, this is our null hypothesis, mu1 is less than or equal to mu2, and this is our alternative hypothesis. Our test is one-sided or two-sided. If we want to, this will confirm from our alternative hypothesis. So our alternative hypothesis is one-sided. Okay, so mu1 is greater than mu2. We are checking that this on an average weight gain in a first population is greater than or not from the second population. Okay, so this is one-sided test. Okay, so this is our one-tail test. So, and level of significance is 5%, so 0.05, and degree of freedom is 23. So our critical value, our table value is 1.714. So T tabulated is 1.714 and T calculated is 2.74. So T calculated is greater than T tabulated. So we reject our null hypothesis. So we check that the on an average weight gain of the first population is less than or equal to on an average weight gain in a second population. So we reject that statement and we conclude that on an average weight gain in a first population is greater than on an average weight gain in a second population. What does it mean? Means vitamins A and D are helping to growth among the children. Okay. So it was the example. Now let's see second example. We have data of 15 males, 15 male TB patients and 10 female TB patients. Okay, and the ESR of 15 males and 10 female TB patients as given below. Okay, so we here in this problem, they didn't give any claim. Okay, so we assume a set of hypotheses in this way, like ESR, on an average ESR in male patients and female patients are equal. So on an average ESR in male TB patient and female TB patients is equal. Okay, and our alternative hypothesis will be two-sided. It could be a greater than or it could be a less than. Okay, so on an average ESR in male TB patient does not equal to on an average ESR of female TB patient. Okay, so this is our set of hypotheses. They didn't give any claim, so we assume two-tail hypothesis. Okay, so it could be a greater than or it could be a less than. We don't know. We just check it's equal or not. So H1 is equal to this. So this is our two-tail test. Same way, we need to calculate all these terms. So we need to calculate combined standard deviation. We need to calculate standard error of mean and T calculated. So standard error of mean is 9.01 and T calculated is 0.68. And degree of freedom is 15 plus 12. 10 is equal to 25. 25 minus 2 is equal to 23. And again, level of significance is 5%. So T tabulated at 23 degree of freedom and 5% level of significance is 2.07. So this is our two-tail test. Okay, so this is two-tail test. So we check this column. We will check value in this column. Okay, so so 0.05 this, and our test is two-tail test, and this column and this same row. So is 2.0, 2.069. So it's nearest to 2.07. Okay, so this is our table value and this is our two-tail test. Okay, so T tabulated is 2.07 at 5% level of significance and 23 degree of freedom, and T calculated is 0.68. So here T calculated is less than T tabulated. So we fail to reject our null hypothesis and conclude that there is no significant difference in ESR among male and female TB patients. Okay, so it was an unpaired T test.